So welcome to my garage. It doubles as my neon shop here. I'm a police officer with Steamboat, so this is just kind of a side hobby business that I have. It's something that I've been collecting neon signs since about 2002, so way before a lot of you were born. I've had that sign for almost 20 years, this one here. Most of the other ones are fairly new acquisitions. And this was always a dream that I had, to learn how to do neon for that whole time. And it's a dying art. There's not very many people that are doing this anymore. So when I bought a house that had a garage, I bought all the equipment and just started teaching myself. So unfortunately, there's very few neon vendors left. The cool thing about neon is it is 100% handmade. There's no machine that can make a neon sign. So it's being kind of taken over by other forms of lighting and stuff. I don't know what they did with the super select market down there. What kind of sign they have now, but they're all the plastic sign. Yeah. And they'll never get the type of character that they have with the neon sign. So my goal with that neon sign is, it was originally an Associated Grocers sign back in the 50s, 60s, 70s, and then it went to the Super Select. So I'm going to restore that sign back to what it used to look like, with the same colors and everything. I'm trying to match all that stuff. And then my plan is to put it on loan down at the museum and have it displayed back down there. I think that, it's a shame when neon gets torn down and never seen again. So we're going to, I'm going to do the letter A off of that sign today to show you all what that would be like. I also have some books there if anyone wants to look at any of those. Got some cool pictures. A couple of them are some pattern books with how the patterns are done and everything like that. So yeah, so a little history on neon. Neon is a gas. It's on the periodic table of elements. It's number 10. This right here is neon. So what we do is we take a glass, we put a couple electrodes on the end of it. These are the electrodes. And we put a high voltage through there. And then the neon gas, or we suck everything out of there. So I've got a really big vacuum pump underneath here, and we suck everything out, and we make a near perfect vacuum inside of this tube. And once it's near perfect, we backfill it with a tiny amount of gas. And this gas here is neon. Would you mind hitting all those lights for me? Off, yeah, all off. And then the other one on the other side as well. Thanks. So this here is neon. Neon is one of the brightest lights, most visible lights that you can have. It is visible from so far away. That's why it makes such a good sign usage. This here is argon. Argon is the other gas that we use in the sign industry. So you see it's very dim, not very visible at all. This tube here is argon with a tiny little bit of mercury in it. So the electricity, it heats up that mercury, makes a mercury vapor, and what we see here is basically the mercury vapor with a little bit of argon that basically is the carrier for it. So back in the 1800s, whenever the scientists were kind of playing around with electricity, the newly discovered electricity, newly discovered gases, all this other stuff, they discovered this. And Nikola Tesla is one of the people that is attributed to that work. In 1910, a French gentleman by the name of George Claude, worked on patenting the electrode. Before 1910, these electrodes, they would basically burn out after just a couple seconds. So they got a cool little science experiment, but it was not good for anything. So in 1910, he patented the electrode. that is able to make a neon sign light up for a long period of time. In 1911, he made the first demonstration of it at the Paris Auto Show. And he had just a really long tube of glass that had neon through it. This is a time when there wasn't a lot of people that even had indoor lighting. So it was pretty amazing to see. It was just about magic for them. And then after that, he started, I think it was 1913, he did the first neon sign for commercial purposes in Paris. So Paris has the very first neon sign. In 1921, the very first neon sign came to the United States, and I think, don't quote me on it, but I'm thinking that it cost them like $20,000 or something for 2 signs back in 1921. So, I mean, you can think about how much that was. It was in San Francisco. It was on a Packard dealer. So that was the very first sign. All right, so this is my wife, Sarah. She brought some waters. Did you want to bring some waters out?
Yeah, there's some water.
So these are how we get the colors in our neon signs. This form here isn't used. We don't use argon without neon or without mercury in the sign industry. In art and stuff like that, they will, but in the sign industry, we don't. So the other way that we get it is with these different colors of tubings. So this here is actually just colored glass. It's all colored, it's clear, translucent. This here is colored glass, and it has a white phosphor coating on it. So phosphor is the same stuff that's on the inside of a light bulb or a fluorescent light and that kind of stuff. And then here you have a powdered blue coating on a clear tube with some additional phosphor on it. So this is called a double-coated tube. This is called a single-coated tube. And this is just a plastic colored glass. So when we put argon through with mercury, it creates ultraviolet light. And the ultraviolet light will light up these tubes to different colors. So you see this one here, it looks yellow, but when we put the ultraviolet light on it, it turns green. So the same thing with this tube here it's a green tube. So when we pump it full of ultraviolet light, it turns green. So this here, this little heart here is a blue tube. If you pumped it full of argon, it would be a real rich blue color. But when we pump it full of neon gas, it turns it into kind of a cool purple. This here would be what we call like a salesman sample here. So you have all the different colors of tubings that you can put on here, and we can change it out. So we can take, let's see. So you can see these two here are the exact same tube. They're both blue. They're both blue, but when we turn on the neon, or the transformer on here, you can see that this one is blue and this one is now purple. It's just the different gases that we're introducing. Judah! Do any questions so far? How is what?
Like, how do we get neon?
So neon gas is in the air that we breathe right now. So scientists do a lot of weird stuff. I don't know. Sorry. I'm not sure. I mean, they have different ways of doing it, just like they have different ways of pulling, straight oxygen out of the air and all that. I don't know how that's
How
works.
is it stored? Like, where are you putting it?
So Mine are in these cans right here. This one here is neon, and this one here is argon. Is that, Lindsay, could you turn that? Thank you. Yeah, it seems so dark without it. Okay. So a couple other cool things that we have here. Let me see if this one will do it. So in order to get these to light up, these transformers, this transformer here is 15,000 volts. 15,000 volts. But it only has 30 milliamps in it. And so even if you got shocked with it, it would hurt, but it wouldn't kill you. So you can see that on the ends of this tube here, it's blue, and then it's kind of red, and it's going to slowly turn all blue. This is a tube that I filled with neon gas, and so it's the red, but I put a little bit of mercury in it. So that mercury is slowly vaporizing, and the whole tube will eventually turn blue. This tube here, I don't know if you can see, Sarah, would you hit the light for me? You can see it's just a real white line just going through it, right? Yeah. So this is what we would call like plasma arc. So this tube here is a 15 millimeter tube, and there's a real high pressure argon gas in it. These ones here usually aren't that high of pressure, but this is real high pressure. And so that's the same thing if you've seen like those balls that have all the lights, you put your hand on it and the light kind of attracts to your ball, and it looks like lightning. That is essentially what it is, but it's just high pressure gas sitting in there with a high current voltage. So that's some of the fun stuff that you can play with. You can also put all the different noble gases can react in the same way. So your krypton, your helium, even your hydrogen, which is a little more dangerous, and then radon as well. So some of the here's kind of a cool one that I have, but this is super, super thin glass. It's 5 millimeter tubing. So it's super, super thin. And that one I just kind of free-handed because it was not very practical. It was just kind of an experiment that I did. So the neon gas or glass comes in all different kinds of diameters, all the way from your 5 millimeter glass, which we call it a tubulation. We just use it to connect to the manifold. All the way up to, what is this, 25 millimeter glass, 15 millimeter, 12 millimeter, and 10 millimeter are the most common for the majority of signs. A lot of the beer signs use like an 8 millimeter glass, but not as many one-off signs use that kind of stuff. So, some of this stuff away. Any other questions? Maybe something a little easier? I mean, how do we...
You say there's not very many people left. Like, how many people are we talking?
So in Colorado, I think that there's probably less than a dozen in Colorado. And, you know, neon, there used to be, back in the 50s, 60s, 70s, there was a few in Steamboat.
voltage-wise and all that ampage that neon can use?
So when you're talking about just the science behind taking a vacuum filled tube or a vacuum tube filled with a small amount of gas, it's a very wide range. In the sign industry, usually the smallest is about 5,000 volts, and which uses about 15 milliamps. So it's a very small amount. The largest transformer that we would buy would be a 15,000 volt transformer that has 60 milliamps. So the 60 milliamps is still a low milliamp. It's not high amperage, but it will make the glass a little bit warmer. So if you have the mercury needs to evaporate in order for it to actually work. So if you have a cold environment and you use argon gas, you need a higher amperage to keep that glass a little bit warmer. Did that answer your question? All right. So some of the tools that we use in neon is we've got a crossfire. So it's literally just fire coming at both directions. We have a hand torch here. This would be used for like tighter bends. We have a hand torch here that we can actually move this around wherever we need it to go. I set my shirt on fire the other day with that, so I'll try not to do that. And then we have a ribbon burner. And so we can take this ribbon burner all the way down to about 1 inch, all the way up to 16 inches. And that's what we make the sweeping curves with. So these blocks here, they're called non-asbestos blocks. Back in the 70s and earlier, they were actually made of asbestos, and then they realized that kills you. So they came up with another product that it doesn't burn. I can see it in fire, doesn't burn. I use this to kind of flatten out my bends whenever I make them. Some different weights that I have just for trying to hold tubes in place. All of our glass is cut in 2 different ways. We either use a file and actually score it and then snap it, or we use this little piece of nitron wire, and it'll actually heat up. We put it around the tube, we heat it up, and then we put a little bit of moisture, just lick our finger, put the moisture on there, and it'll just crack the tube. So I'll show you a couple of demonstrations of that. We have a tube checker, so we know what diameter of glass we're using. So we can hold that up in there. We can see that it's a 15 millimeter glass. Whenever we go to make a bend, a sharp bend, it's like a hose. You ever take a hose, a garden hose or something, and you bend it and it kinks? So we can't have that. If it kinks, the gas can't flow through it. So we put a cork on one end of it, and then we put a blow hose in the other end of it. And so you'll see me today, I'll have this blow hose. I'll have one end in my mouth, one end in the tube. And then I'll heat it up, I'll make a bend, and then I'll blow that out to expand the diameter of the glass again. And then we have marking pens and so forth. We use this screen, we put the screen down, and it just leaves just a very small, minute barrier between the paper and the hot glass, and so it doesn't burn the glass. And this is just for kind of, it just has some of the non-asbestos stuff on there. It just helps pinch the tube if it gets blown out a little bit too much. We call these finger savers. So we can use these for putting, when we put an electrode on, we can use it so we're not burning our fingers, or if the piece of glass that we have is just a little too short, we can put that on so it doesn't burn it. These fires are about like 1,500 degrees or something, so it doesn't take long to heat up your fingers. So, any questions on any of the tools that we use? And I'll get into all this fancy stuff here in just a little bit. All right. So the first thing that we need to do if we're going to make a sign is we need to know what we're going to make. So we're going to need to make a pattern. This here is the A that came off of that sign here. It burns white currently. I'm going to make it so that it goes orange because I want to use the neon gas instead of the argon. Just simply because it gets so cold, it'll make it brighter. So we're going to put it face down. right on the table. And then we'll just take a pen. So neon is the ultimate craftsman, art, science, all just combined into one. And that's what makes it so cool. You know, every single piece is handmade. No machine that can make it. So every piece of glass that you see out there, every neon sign that you see out there, you know that some person burnt their finger trying to make it. That's usually inevitably what happens.
I had a question.
Yes.
So, when you're screwing in like a light bulb under the microwave, light, you're not supposed to touch it because the oil in your hands will make it burn out faster?
Yeah.
Is that the same with neon?
No, so the reason with that is those are halogen lights, and so they burn super hot. And so what will happen is there's a coefficient of expansion in glass, and it basically is how fast that glass can move and expand and contract with heat and cool before it'll break. So what the oils in your hands will do is it will make it so that there's a different temperature there when it heats up, and it can thermal shock the tube. All right, so I have the pattern here, and if this wasn't an A, it would be backwards. So if this was an F or something, it would be a backwards F. We do it backwards because we want to have the front of the tube perfectly flat, because that's the side that you see, and then all the bends are going to be on the back side. So you see, like here, all these bends are on, I don't know, this was part of that 0 days neon. I don't know if you guys have seen that. But, so all the bends are on the back side of the glass. Here, everything's on the front. So you do everything in reverse. It's inevitable that we'll get through a whole tube and realize that the pattern was the right way and not reversed. And that's annoying. So the other thing about this tube here is our neon tubes come in 4-foot lengths. This tube is longer than 4 foot, so we're going to have to make a longer piece out of 2 sticks of glass. And we'll do that after a couple of the bends are made. It's just a little easier. And remember, this was a green stick glass. But we're going to put neon in it, and so it's going to be orange. So I'm going to start right here. So I'm going to want my glass to go up this direction, so I'm just going to turn my pattern so that it has a better access. This is just a China marker, just a wax pencil. And I just use that to make my marks. So when I'm making what would be a 90-degree bend, the amount of glass that I'm going to heat up is 2 widths of the glass. So I'm going to make a mark. I'm going to make 3 marks there on the glass. The first mark goes right in the middle of the bend, and then the other 2 are just how much of the glass I need to heat up. So we got to turn the glass as we go because we need it all to be evenly heated all the way around. We can't just have one side of the glass heat it up more than the other. Otherwise, it'll make one part of the bend super, super thin, the wall, and then the other would be a lot thicker. So it's getting super soft now. So now I'm going to heat that back of the bend, because that's where the bend is going to be. I just want that to be a little bit softer. I'm going to bend it. I'm going to blow it, and then it's going to make that 90-degree bend. Then I'm going to just set it down on my pattern. Take my block, and just make sure it's flat. I'm going to move on to this next one. This one's going to be a 90-degree, or a 180-degree, so I'm going to bring it back over. And for that one, I need to heat up about 3 times the width of the glass.
How long do you have before the glass starts to get hard and you have to reheat it again?
Seconds. Not very long at all. Yeah. And if I mess up, if I stick it back in the fire, it'll crack. So you get one shot. So it's starting to get close. So that little tool just helps it so that it wasn't just perfectly round on the inside. There's a little bit of a kink, and so I was able to just fix that out of there. Put it back on my pattern. Make sure it all looks good, which it does. So what I'm going to do is, in order to try to keep the front of the glass looking real good and without any slices, I'm going to make the splice in the back here. So I'm just going to mark right there. And then I'm going to take this tube, and we're just going to set it aside for a little bit. And I'm going to move on to the other part of it. So I'm going to mark on my pattern here, and I'm just going to kind of make a couple marks where that curve is. And take my glass, make sure that I have enough glass there on the end. I'm going to mark where that starting curve is. And then I'm going to take my blow hose, flexible, and I'm just going to lay that down on the pattern. And now I know exactly how much glass I need to heat. Now I'm not going to do a sharp bend here, so I don't need to have my blow hose for this. And this is longer than my 16 inches, so I'm going to do this in 2 different bends. So I'll do one bend here, and that'll get me halfway around my curve, and then I'll finish it off. I can make this a little bit hotter here. Taking a little longer than it should. See, it's starting to get pretty flexible there. Not quite there yet. Just gonna rock the back of that bend there. Throw it down on my pattern. Take my block, just flatten it down. And now I've got half of that letter. So I'm going to wait for this to cool off just a touch, mostly because I need a place to hold it. So I'm going to move on to a different part of the glass, and I'm going to do this one here. Now I need to bring this up so that it's at the same level as this. So that's about right there. So this here is just a block. We call it a block. It's just a couple of tubes taped together, and that's going to be so we can raise this bend up. And this one I'm going to need a blow hose for. So sometimes it's easier for me to use these tighter bends and just use the ribbon burner still. So that's what I'm going to do here. Sometimes you get a little more even heat. Heats up faster. Starting to get pretty flexible now. Now I'm going to let kind of gravity just take it a little bit. And I'm going to swing it over. Have my block there. That wasn't the best bend, but hopefully it'll work out. It's still pretty warm. Put it on my cooling rack. Now this right here is where it plugs into the sign. So if you look at the casino sign right behind you, these are called housings. And so that's where the neon just plugs right into those. So I've got to make that bend there so that it can plug into the housing. It's not liking that. I'm going to use this too. I'm going to take this and just make sure that it's straight up and down. Looks good there. Now I'm going to put an electrode on here. So if you look at these electrodes, you've got one that's closed-ended and then one that has a tube sticking off. So the one that has the tube sticking off, that's how we hook it up to the manifold over here. So I've got some marks on here that are going to tell me exactly where I need to So I just get my finger a little bit wet, heat it around there, and it just breaks right off of there. Try not to set myself on fire again. So now we're going to heat just the edges of these here. We're going to get them to the point where they're going to start to melt. We can see it because the edges all start to go soft. And we just touch it together. Keep heating it. There you have it. Turn 2 pieces of glass into one. One of the reasons that we put these up in the air like this, if I keep it on the table to cool off, this table is fairly cool, so it'll shock that glass and it'll break it. So we already started this bend here, so I'm going to go going to find right where it starts leaving my pattern, and I'm going to go just about a ½ inch in from there. Now I know exactly how long I need to heat up. It gets pretty hot in here in the summertime. So back in, I think, the 40s or 50s, Steamboat had one of the only neon sign shops in Colorado. There was a couple in Denver, one in the Springs, one in Grand Junction, and the other one was in Steamboat. And all the businesses downtown had neon signs. Yeah, if I put it right on the paper, it'll burn it. It'll immediately just set it on fire. It is. You know, I have one whole side already bent. So the neon work isn't going to take that long to do. It's trying to, one, I'm not making any money on it. So it's something that I'm just donating back. Well, I'm going to put it on loan because I don't want them to fall into a hard time and sell it or something like that. So I was just going to put it on loan down there so that it's displayed, but they can't get rid of it without my consent.
Are you displaying at the Lions too?
That's who I've been in talks with, yep. So they can't, it's so big they can't put it inside. And they can't mount it onto the side of their building because it's a historical building. You can't actually change the exterior of it. And so we're gonna make some sort of a stand for it, and then it'll just be freestanding. They own that little old gas station across the street as well, so they mentioned that that spot might be a good spot to put it. So I'm just using that just to kind of, I got this out of line just a little bit, and so while it's still hot, I'm able to use this to kind of just push it into place a bit. So now, you can look at this. This? Yeah. Yeah, these are nice to have. Because if you don't have it, you have to actually score the glass with a file. And then snap it in half like that. You risk cutting yourself a lot more that way though. So these cutters are real nice. So there's this little bit of phosphor in here, and if I don't remove that phosphor when I weld it together, it could leave a little pinhole. So I've got to come in here and remove just enough of that phosphor.
Are you using like a cork or some of the sandpaper on it?
It's just the cork. Yeah, it's just powder, so you can actually just wipe it off with your fingers. But you only need to wipe away about 1/8 of an inch or so of it. So, the problem I have here is I didn't do that bend good. So I'm actually going to come in here and slice a little bit. Sorry. It wasn't fitting together. This bend wasn't high enough. So what I'll do is weld this together here, and then bring it down to this piece. And then we'll be able to hook it up to the manifold. That's where the fun begins. See if I can do this without creating a thermal shock on the piece right below it. finger shaver comes in. And so I've got to be careful because I've got that bend right below there. So I've got to try to heat this up without getting too much of the heat onto that bend below because it could crack it. Now, we'll end up coming back and just sticking this piece onto this. So I've got the cork in one side, the blow hose on the other side. And you can also do this with the hand torch and bring it over to the table. I like doing it on the crossfire better. I think I get a better weld with it. Stick that other electrode on. We're going to put the closed electrode on now. Finger saver comes in real good when you have a short little stubby electrode like this. Just don't want to burn yourself. And I do it a lot. So I've got to try to, you know what? I think that I'm going to do this with the hand torch. You can see that. So I've got all these different weights. This is just filled up with lead shock. You'll see I have this little notch cut at the table. That way I can just kind of access this in a little more if I need to. The hand torch is definitely not as hot as the crossfire, so it takes a lot longer to... I don't know why that's going out on me. Doesn't help when your fires go out when you're in the middle of it. So I've got to heat it up, make sure I don't get any leaks in there. If I have a leak in there, it's not going to pump good. All right. Now we've got the electrodes on there. Looks like an egg. So now this here is how I do all of the vacuuming out, filling, everything like that. So this is all Pyrex glass. It's all scientific glass, essentially. I've got a big old pump underneath here. That will suck it down to pretty much a perfect vacuum. This big beast here is, it's called a bombarder. So it's a giant transformer. That is the one that doesn't have low amperage. That's very high amperage. It literally looks like I just took it off the pole. It didn't, but looks like that. Here is a milliamp meter. So while I'm doing this, I'm going to have to adjust the milliamps so I can get different temperature results in the tube. I have a temperature reader here, and it'll tell me exactly what the temperature is. This is in centigrade, so if I mention a temperature, it's going to be a temperature in centigrade. I've got my argon mixture, my argon gas here. I've got my neon gas here. I've got the two different control valves for that. This valve here goes to my, let's see if I can move this. This here will tell me my microns, so how much vacuum is pulled into that. I've got a main control stopcock here, which will control the suction. From there, I can close off the pump from everything else. A couple other knobs here. This here is called a U gauge or a manometer. So this will tell me what the torr is, or the millimeter of mercury. So they call it millimeter of mercury because these originally had mercury in them. And that's how they were able to determine the pressure, is how high up that mercury went. We now use a synthetic oil. We don't use mercury in there for obvious safety reasons. So this little gauge here will just tell me exactly how much. Depending on the diameter of the tubing, depends on how much millimeters of mercury that I need. This back here is a diffusion pump, and I don't actually use it because the pump that I have down here, it pulls such a good vacuum, I don't need a diffusion pump to control it. This here is a a spark coil, a high frequency spark coil. So when this is on, it creates some high voltage. So I can turn it on, you can kind of hear it. And you can actually test tubes with it. So this tube's broken. That tube is good, that tube's good, this tube's broken. And I use this to determine if there's any holes where I did my welds. If there's a hole, it'll attract right to the hole. This electric current will attract right to the hole. So, it's going to get a little bit louder in here because I'm going to turn on my pump. You'll see me moving these gauges around. I'll try to be as, try to talk through it as much as I can. So the first thing that I'm going to do is make it so that I can hook up my my tubulated electrode to my unit here, or to my manifold here. So I'm going to start just by adding a little bit more tubulation to this black. That doesn't have to be pretty, it's just the way to connect it to the tube. And then I'll add just a little bit of a bend here. So now I'm going to connect my blow hose through my manifold because it's going to be completely connected to my manifold down, and I'm not going to have an open end here. So I've got a little spot right over here that I can connect it to my manifold, and now I can blow through this. So now I'll open up my stopcock and it'll start pulling a vacuum. And I'll be able to turn my high frequency spark coil on. And you can start to see it kind of light up. So now all I'm doing is I'm just looking for any holes in any of these welds that I did. If there's a hole there, I'm not going to be able to get a vacuum. Check all the different welds that are on my unit here, and we look good.
If you have a hole, would you have to start completely over? Or you
Nope.
just heat it?
I would just heat that section up and try to weld those back together. If you do it right, you usually won't have a hole, but sometimes you get one and it's a pain when you do. So I'm going to try to find about the middle of the tube here because I have this little stroke in my A. I'm going to put a little more on this side. And now I'm going to hook up my bombarder. We want to make sure that nothing lays across this tube because it'll melt that. It gets so hot. It gets up to about 300 degrees Celsius. So what would that be? 600 something degrees?
So that's why the glass tubing is the surface it's setting on and not the counter.
Exactly. Yeah, I have this glass tubing here. Otherwise, it would cause a fire there. So before I start putting an arc in, I'm going to take some of these mica sheets, and electricity doesn't go through mica. So anywhere that the tubing runs real close to each other, we're going to put a piece of mica. That way it doesn't shoot through the glass and make a shorter connection. Electricity always follows the path of least resistance. All right, make sure everything is shut down here. I'm going to turn on my bombarder and I'm going to check to see if I have a vacuum. I've got enough of the vacuum. It's all pulled, there's enough of it pulled out. So now I'm going to heat it up. This is called a choke, and I'm able to control the milliamps with this choke. So I'm going to heat it up to 100 degrees Celsius, and I'm going to do it at 200 milliamps. And because it's a bigger tube, it's going to take a little bit more time to actually heat up. So right now we're at about 50 degrees Celsius, so that's about 100 something degrees Fahrenheit. All right, we're right at 100 degrees Celsius. So now I'm going to open up the main stopcock here to my vacuum, and we're just going to suck out all of those impurities that we just burnt up. So everything that was in my breath that I breathed into that, any dust that might have made its way into that, and we're going to just try to get a perfect clean environment on the inside of that. So we're going to let that just pump down for about 45 seconds to a minute, and then we'll continue on. Any questions? No questions? Any other questions? What mica is? That is a good one. Here, Zoe, will you pass that around? So mica is just a form of a rock, and it's just a sheet. All right, so now I'm going to close the main stopcock, and I'm going to close the stopcock on my manometer, and I'm going to inject about 3 millimeters of mercury, or 3 millimeters of atmosphere into this tube. So I've got this little spot here that allows air to come in, and I'm just going to unscrew that until this little bit of oil here comes up to the 3. And I don't know if you guys can see that at all. All right. So now it's at the 3. So this oil has come up to the 3, and we're going to keep going. So now we're going to do 200 milliamp again, and we're going to go all the way up to 150 degrees Celsius. And so you notice now how the color is different than what it was just a second ago. That's because the atmosphere that I just let in, that's the air, all the air molecules, all that dirty air, the dusty air, all that stuff is getting burned up again. And so you'll actually see this kind of change colors throughout this process. All right, we're at 150 degrees Celsius, and now the pressure in there has moved this up to 4 instead of 3. So we need to bring that back down to 3, so I'm just going to open up my main stopcock very, very slowly until that comes back down to 3. And then we're going to keep going. So now we're going to increase the power up to about 300 milliamp. So I'm going to pull on the choke until that gets up to 300 milliamp. And we're going to take this up to 200 degrees Celsius. You notice those electrodes on there are starting to get real warm, and we're going to have to get those real, real bright red. Okay, so we're going to come over here, and now we're all the way up to 5, so we're going to bring that down. Now we're going to bring it down to 2, so that there's a little less atmosphere in it. It'll help heat up those electrodes a little more. And we're going to increase this all the way up to 425 milliamps. And we're going to go up to 250 degrees Celsius.
So what causes the color change in it right now? It's part of the stuff inside of it, but from green to the white color.
It's the air and all those molecules in there right now. So right now there's still gases in there, just not mercury or neon. It's oxygen, anything else that's in the air, all those dust particles. So now we're going to bring this down to half a millimeter, and we're going to get those electrodes super, super hot. And so we're going to crank that thing up. So now that oxygen and stuff is just burning pretty much just white. And we're going to get those what we call cherry red. So we're processing the electrode right now. There's a little bit of a coating that's on there, and we just want to make sure it gets burnt all the way off of there. And now we're going to open up the main stopcock, and we're just going to let it suck all of that dirtiness right out of there.
You can kind of see the orange in there. Right in the...
Yep. And so now we're going to be able to see these microns dropping down. So this isn't completely accurate. When it gets down to about 44, negative 044, it's about perfect vacuum. And we're going to take it, we're going to wait until this tube gets down to 100 degrees Celsius before we can add the gas back into it. You can't add it to it unless it's cooled down enough.
How do you know when it's cooled down?
I've got the temperature gauge right here.
How long does a tank of gas last you?
How long does what?
A tank of propane last you?
So I'm actually connected straight into my natural gas.
Okay, gotcha.
I have that there, and I've got it set up so I can use it. I usually don't use it though. It's cheaper just to hook it up to the natural gas. The propane will burn hotter, which is nice, but I don't want to keep running back and forth with it. So So I just have it hooked straight up to my house. Makes it nice. So it's still, we're about 2 microns away from it being pretty much a perfect vacuum, but we still got to let it get down. It's about 200 degrees right now, so it's dropped about 100 degrees. So we need to just drop it down to another 100 degrees, and then we'll be able to fill it. Did you guys look at any of those books over there, of any of the old neon signs and stuff? So these ones are kind of how the patterns are laid out. They'll explain how to make the patterns and everything. Letter H and stuff. Yep. The problem with having it connected to your house is sometimes the fluctuation with the gas fluctuation. If my heater kicks on or something like that, it can pull some of that gas out. We've got about another 50 degrees to go. And remember, this tube was red, or was green, whenever we lit it up. So it's going to be orange now. This here is a 1 pound jar of mercury.
Is it really, or is it a substitution?
No, it's mercury.
It
Yeah.
really is?
Yeah.
It's actually a pound. Like that little thing is a whole pound.
Yeah.
So it's very dense then.
Yeah. So I have this little syringe here, and whenever I have a mercury tube, which would be anything that has argon in it, what I have to do is I've got to make a mercury trap. And so what we'll do, see if I can, that piece is a little too, I have to burn my fingers off.
Where do you order your glass in from?
Where do I get it from?
Get your tubing and such.
So there's a place down in Denver called Genco Sign Supply, and I order a lot of it through there. I just found a place out in Minneapolis that will actually send it to me, and some of that glass is actually cheaper than even after I paid $100 to ship it. It's cheaper than getting it from Genco. But there's a couple places in Denver that I can get it from, or I get it shipped in. So if I was making a mercury tube, or one with argon, so usually the argon ones are going to be the cool colors, and the neon is going to be the warm colors. Oh, a little too much. Let me do that again. one didn't come out as great, but we would have this in between here and our tube. We have a little ball there, and then we just put in a tiny, tiny bit of mercury. That's super hot. Careful. See that little ball there? So mercury is a metal, but it melts at ambient temperature. So it appears as a liquid. It's also poisonous, so we have to be very, very careful whenever we deal with that. And so we would process the tube with the mercury sitting right here, and then after we process the tube, we would seal it off on this end, have that mercury dump into the tube, and then we would cut it off on this end as well. And that way, that mercury is in there, and we don't expose ourselves, and we don't expose it to the heat. So we're cool enough now. So I'm just going to give this a little bit of a shock here, and it didn't light up, so that's good. It is on, yep. If it doesn't light up, it means that it's a perfect vacuum in there. There's nothing in there for the electricity to interact with on there. So now we're going to close our main stopcock. We're going to cut it off from the vacuum. We're going to close our manometer. And we're going to, because this is 15 millimeter tubing, we're going to bring that up to 9 millimeters of mercury. So now this is coming out of this tank right now, and it's being backfilled right into it. Because there's nothing in that tube, it's a vacuum, it's just going to suck the gas right into that tube.
So this is a more efficient, safer way to put the mercury in the tube than with
Alright, so now we're just going to test it, and it works. So we're going to turn off our bombarder. We're going to unhook all this stuff, and then because it's still under a vacuum, all we're going to do is we're going to heat up around this tube here, and it's just going to suck that tube shut once it gets molten here. Now we have our neon tube, and we're going to hook it up to. Let me turn all this stuff off, actually. Hear me? So this transformer here is what we would call a burn-in transformer, and so this is just going to make sure that it gets up to the proper color and everything on the table here. So you see how the color's kind of turning in? Hopefully, if I've done it right, that'll all turn orange here in a minute. Did you have a question about the mercury?
I think she answered it.
Oh, okay. So you see how it's no longer green there at the end? So we'll usually just let this sit for a while, just to let it burn in good. Yeah. Any questions on it?
How hard would it be to set up this kind of stuff for yourself?
It was, there's not a lot of resources for it because it's not something that you can't just go onto Google and Google it. There's not a lot of stuff on there because it's just not that used of a technology. So it took me a while to figure it out because I had to learn myself essentially. There's a couple good Facebook groups that I'm part of that are real helpful with some of the vendors. I bought all of my equipment from a gentleman that shut down his shop down in Arizona, and I hauled all of it back in a trailer, and he kind of set up a couple diagrams, but it wasn't that good. So I had to go on, and I'm fairly competent when it comes to electricity, so I kind of know how current flows and stuff. So I'm able to kind of figure it out. But I stumbled through a lot of it, made some mistakes. Luckily, didn't shock myself. So, yeah, it's super fun though. I love doing it. It's never one of those things that's I'll be able to retire off of, but if I could fund my hobby and, my goal, I'm sorry? Oh, okay. My goal is just to kind of have these things visible for people, like the one in Oak Creek. I just want it to be visible. I just want people to see it and enjoy it. Hopefully we can get other people interested in it, and so they carry it on. Out of all of the neon signs that used to be hanging in Ralph County, the Rabbit Ears is the only one that's left now.
I read an article in the paper, I don't know, it was some kind of history, something a year or two ago, about the reason all the neon disappeared is because they went through a phase where they outlawed it in town because it put off too much light or something.
Yeah, so it used to be, Steamboat used to be known for their signs. Every single business had a big sign hanging off the side of it.
Yeah, they had.
And it kind of went through a negative imagery. The liquor stores and Las Vegas and all this stuff had neon, and then people started to not want to be associated with that. Along with the plastics and stuff becoming more readily available. That started phasing it out. So in the 90s, Steamboat completely banned neon. So you can't even put up an exposed neon sign inside the city limits of Steamboat. And they just redid their sign code, and I tried to get them to add it, but they wouldn't do it.
So how does the Rabbit Ears Motel,
It's a historic landmark.
Oh, gotcha. So
So that one is exempt from it.
So the select sticker sign, was it just too expensive for a small business to maintain?
I think so. So I found out that they were taking it down to the newspaper article. One of my coworkers sent me a link to the article saying, "Hey, are you redoing this sign for them?" I'm like, "No, but if it's coming down, I want it." And so that was the night before, they were tearing it down at noon on the next day. And I got off work at 6 o'clock and just started making phone calls. I ended up calling the paper to get them in touch with the owner, and they said, "It's coming down. If you want it, then pay for the crane." And so they already had all that arranged, and I just showed up and paid the crane guy, and they put it on the trailer. It's super sad. I would love to have seen it just stay there because it's iconic.
I know. I was like,
But-
why did you take that down?
And it upset a lot of people. But so there was 3 options with it. There was one guy that wanted it that lived in North Carolina, I think, and he had a second home, and he's like, "Oh, I'll take that. It goes to the dump, or I got it." So the museum contacted me the next day and to see what my plan was with it. My plan was never to fix it and sell it or anything like that. It's just those things need to be on display. So I'm going to redo it to the original.
What about the paint and everything? You do that hard to do?
Yeah, so I actually used to be a sign painter back in the early 2000s. So I've got a little bit of knowledge there with that. So I'm good there. My biggest thing has been trying to strip the old paint off of there. Yeah, so I'm trying to do that without paying the $700 for the sandblaster.
Yeah.
So, yeah.
It's really expensive. Like, can I just like hear how much? I don't want to like ask you for some money, but I also want to get an idea
Oh,
of
yeah,
how
you're good.
expensive it is to repair something that large. Like,
Um,
just trying to get an idea.
So I put it all together, and the transformers are what are really expensive. Outdoor transformers are just ridiculously expensive. So that's, here, I can show you some of those. Excuse me. This is one that actually came out of that other liquor store sign that's out there. This is an outdoor transformer. This is a really old one. But these are 15,000 volts, and these are what is going to be my biggest expense in repairing that sign out there. And then I'm trying to save as many of these as I can from the original, but these are the housings that are on there. If I have to replace the housings, it's going to cost me like $500 just for these housings. And so those are the ones that I'm trying to, and the sandblaster quoted me $700, and so I went out and just bought some paint stripper, and then I realized that about a year ago the government took the active ingredient out of those, and so the new paint stripper doesn't work. Luckily, I found a couple gallons over at Ace Hardware of old stock stuff, so I haven't tried it on it yet, but I'm pretty sure that'll work. So it'll be time. The paint for it isn't too bad. I'm gonna have it custom made though for the right colors. Yeah. So it's gonna be.
So like, how much is a transformer?
Those transformers are about $200 each. So, and it takes 3 of
So
them.
that's a big donation.
Yes,
Okay.
and it will be.
Do you do that a lot? Like,
I haven't yet. So this is kind of upstart for me. So it is, but that's one of the reasons why. And she called me up and she's like, well, we'll see if we can maybe get a grant and we can just pay you for what you have in it. I'm like, well,
the museum said that?
yeah, and like if I put my money in there and if I'm putting all my expenses into just basically giving it away, I would much rather just put it on a loan for you.
Yeah.
And, it can be an indefinite loan or whatever, but that way my name is still attached to it. That way if they ever need money, they don't just start auctioning it off and then, it goes somewhere else. So,
Well, thank you.
but I'm excited to see it out there. I've got some of the, let's see here. So on the circle, instead of the Super Select, it was an Associated Grocers, and so that's what these are. This will be. How does this fit together here?
The logo?
Yeah.
Oh, that would be so cool.
Upside down. So it'll fit in like that. Yeah.
Oh, that's so cool.
Yep. And so I've been playing with paint samples and everything, trying to find the right colors, and I'm down to somewhere in between these two colors is what the original orange was. And the original glass, where is that? So very few of these were actually still any good. The A is one of them that was. So the original was white, but again with the if it's super cold outside, that mercury doesn't vaporize, and so it would be super dim like that down there. So I'm going to go with orange because the rest of the sun is going to be orange. The circle itself, the neon circle will be white still, so it'll be white and orange neon. So,
And what museum is it going to?
what is the museum down in Oak Creek?
Tracks and trails.
Tracks and Trails.
Okay.
Yeah. So I haven't gone down there to talk. I talked to the lady over the phone. So pretty good match.
Yeah.
I talked to her on the phone about it, and she told me they can't put anything on the side of the building. So there, it would either have to be like tucked in the back there where all the other antique mining equipment is, or we'll see about putting it on the other side of the street next to the where the old gas station is. So yeah, you look back up again.
This is the best field trip ever. Thank you so much.
Well,
Yes.
good. I'm glad that you enjoyed it.
Yeah.
I love this. I've been looking forward to someone reaching out and being like, "Hey, we really want to come over and check it out." So I was really excited whenever you reached out to me about that. Super excited about it.
Yes, thank you, Brandy.
Yeah.
This is
It
awesome.
was, we were actually shopping for signs, like trying to figure out what we want to do because we bought the old black dog yet and we want to do some, vacant whatever
Oh,
signs.
okay.
So now we're trying to figure out after you gave us the quotes, okay, now we're like, okay, so where do we want to put it? We need to make sure we know where we want to put it to make sure we have the right dimensions for it or whatever. But I thought, how cool would that be? So I was really
Yeah.
excited to even find somebody local to do it because we had been looking outsourcing other places, and so it was really neat to find
Yeah.
somebody that was local. And
Yeah, I'll be happy to help.
so.
I'm working on a couple signs for black iron or big iron coffee.
Okay.
So that's what those are for, and I did the one for zero days ice cream, which is actually really good if you guys haven't had it. It's over in the new Steamboat Fun and Games shop. It's actually pretty unique.
Did you do the
ice
Soul Man?
cream. What?
It's like in Oak Creek across from that gas station that you're talking about.
Oh,
There's a shoe shop.
yeah, that has
They
a
have a
really
neon
old neon. That's
It's
old.
a really
That's what it
beautiful
says. I thought that
sign.
was
Cool.
Really?
Yeah.
It's like an antique.
Oh yeah, that one's a really old one.
Do they do you have to repair them? Do you do that?
I can if it has mercury in it, then I won't repair it because
Yeah.
I don't want to expose myself to that.
Yeah.
So those tubes we just throw away. So all these, I've never repaired one of these. That's one of the benefits to, and one of the decision makings in making these red as well. I can repair this. There's no chemicals in there or anything. Neon is an inert gas, and so it doesn't. It's clear. It doesn't smell. It doesn't harm you. So there's nothing dangerous in this one. So the white ones that has the mercury, so you can't fix it.
How do you throw away an old one with mercury in it?
I collect the mercury, and I actually haven't had to dispose of any of it yet. I've got some mercury collection stuff, but there's companies that you can basically donate it to, and they redistill it and resell it. So, So yeah, these are all just a bunch of old tubes that I got all these down in Granby, off of some old sign shop. Some lady bought this building and had all these old tubes in it. So
Is that California?
yeah, so it's actually a really cool Coors sign. It'll flash and it'll say Coors for California, and it's actually a really cool sign. And then I've got a ton of old beer signs and signs hanging up everywhere. So, yep.
Do you want help carrying all your chairs back into your house?
It would all be great.
Yeah.
Okay.
If we could all just
One
carry
willing to
one,
carry a chair.
it's just.
So, and the only ones that need to come in are the kitchen ones. Yeah. But yeah.
Okay. Well,
Very
thank you
good.
very much. Thank you so much. It was
Absolutely.
so cool.